I'm going to talk today, but possibly less familiar with the research and how we've extended it under this contract under ABI from this post-Grenfell research work stream. So without further ado, carry on. As Dominic said, if you have any questions, do please send them over to him, and if there's anything I'm in a position to answer, I'll do my best at the end. And I should just tell you the shape of this webinar is slightly different in that one of the deliverables of this research program was a video to help extol the virtues of going to high integrity type detection systems. So the final sort of 12 minutes of it will be showing this video to you, and then I'll be just returning to a final slide for closing. So I should first of all just give it to those who sponsored the work in the shape of ABI and their membership. Jonathan O'Neill, our Managing Director, lead for this piece of work. FPA laboratory staff for the work they conduct, and the three organisations that also contributed immensely by way of provision of kit of parts in the shape of Siemens, Johnson Controls, and Honeywell computers. Sorry, Honeywell systems. Now, obviously, following Grenfell, the focus has been catastrophic loss of life, an extraordinary external fire spread both horizontally and vertically around the building, and we've seen great confusion with the legitimacy of design, material selection, advice, interpretation of regulations, and test and approval methods. But there are two which we sort of touch upon today, which I can't help feeling are related, are the dreadful consequence of stay-put fire policies and concerns around detection system application. So we've heard in the news about how the alarm systems aren't necessarily connected, and also with stay-put fire policies, we do see that, well, actually we need to be very clear on what that actually means. We've seen some inappropriate use of the wording in the press recently. Really, the stay put, you are safe, and that is a property of the building that is established long before any fire event. And then we also have stay put, and await rescue, which is a decision that's made during firefighting. And I do see a lot of problems with terminologies in the press there. Can I just ask, so I'm getting some noise through my phone here. If anyone has their microphone on, is there a possibility they might switch it off? It's just giving me quite a lot of noise back here. Thank you. Right, so, but I can't help feeling that some of the decisions made around particular policies for managing fire, evacuation, and how it's managed, at the heart of this is, are problems with an assumption of the poor performance of the fire detection systems that we have, and how readily they go into alarm when actually, there is no need for a fire and rescue service response. So I'd like to discuss some of those as we go. Now, obviously, when we went to, we were asked to produce a number of research themes that might help us address some of the issues that came out of Grenfell. I won't go all through these, but clearly they are very extensive. We came up with 14 research themes, and some of them are in our gift to change, others aren't. Some of them are quite basic things about like how we can engage with DCLG better, who seem to often ignore what we have to say, and there's very little scope for engaging well with them to try and get our messaging across. Other things we can do something about. But the three things to be taken forward, obviously, were to do with cladding systems, which we had a webinar some time ago out on. This is the second series on detection, and there'll be a final one on sprinkler systems, and this is on the standards and relative performance of sprinklers. Really looking to try and improve the quality of residential sprinkler systems so they don't actually, at the end of the day, end up creating other insurance problems by way of escape of water. In respect of this work, what we were seeking to do was to build upon the work that we really did in 2014, which we presented well, we managed to achieve a seat at the BRAC table, that's the Business Regulations Advisory Council, where we were campaigning for a range of issues, of which high integrity detection was one. So this work really started with a literature review. We then started looking at recreating scenarios and looking at comparative performance in different types of detector systems or detector heads. Phase 3 was produce an educational video, and then really phase 4 is really to use this work to start winning hearts and minds and get people specifying a higher level of detection or better detection than we currently have at this moment in time. For those of you who may remember back in 2014, we encouraged you to really make the then Fire Minister's life a misery, the Minister who had responsibility for the building regulations by bombarding him with postcards. This was done when really all other approaches that we tried by legitimate routes had failed and we were getting nowhere. But really, we were looking for to campaign for three things. Mandation of high integrity detection was right up there at the top in all new commercial buildings to solve the unwanted and false alarm issue. Mandation of fire sprinklers in warehousing over 4,000 square meters. Currently, they need to be in buildings over 20,000 square meters, which is obviously a very large size in comparison to our European cousins. And really to have a fresh eye look at whether building regulations are keeping up to date with innovative building techniques. And ironically, we were looking at issues to do with fire ingress and combustible voids. Now, in terms of automatic fire alarm, we drew a lot of conclusions from that. Really, we consider the system to essentially be broken. False alarms are so prevalent, really, over 95% are unwanted. And by unwanted, we mean sort of burnt toast, smoking. So these are things which, whilst they have the hallmarks of fire, they are not anything that you'd wish a fire to turn up at your door for. Or false alarms, and these can be things like shower steam, dirt, dust, other challenges, or even electrical interference. You know, things which never were fire and never should cause the alarm to sound. But with statistics like that, everyone really has started to adopt coping policies. Many fire and rescue services no longer turn out for automatically generated fire alarm signals without other actions being taken. And those other actions might be, phoning up the occupant to see if there really is a fire, or waiting for a 999 call. Different fire and rescue services have different policies of call challenging, but at the end of the day, it can lead to delay or non-attendance at all, and clearly that is not something which we would like to see. As a result of this, really, if detectors are not going to actually impact on the event outcome in the way that they might, obviously it reduces the level of insurer interest in them. They are there for as a life safety measure rather than having any benefit for property under this situation. And we also know that some owners might be switching off their systems as, again, another coping mechanism for false and unwanted alarms. Might be the punitive measures being taken or people being fined if they go off. Again, this can lead to delay, safety and legally also. Fire and rescue services also, been advising people to go back in and check if there really is a fire. And I know that certainly contrary to what I was taught at school. But again, that can lead to safety issues and delay also. And probably the final, they are there as life safety systems, but ultimately if the occupants stop believing in them, it's problematic, and maybe they might not take the action that's required to save themselves when it really is a true incident. And really, we need to get people having a fresh eyes look at this. Can you think of any other fire safety protection application where such poor system performance is tolerated? And I do mean as a system. We're talk about every certification to installation to maintenance and design in the first place. It is immensely problematic. But I think throughout certainly all the methods by increased levels of maintenance have been tried for many years now, and really we're not seeing the rewards from that you would expect, and it's time for something different. just to show you different methods that fire and rescue services have for coping, we have which you might be able to, which you should be able to log in on the Risk Authority website. And if you look at that, there's a nice tool which shows you the different responses provided by the different fire services. And they range from, no attendance for an unconfirmed automatic fire alarm, right down to a sort of standard, no call filtering. But they are different for the different types of occupancy category, and they can be very different also as to whether it's day or night that we're talking about. So there really are as many different policies as there are fire and rescue services, in spite of CFO's best efforts to produce a common process. But I think on the left there you'll see that really a rather staggering statistic, that really of about 500,000 attendances in a year, over half of them are in response to false or unwanted alarms. And that clearly isn't sustainable in the longer term, and hence all these coping policies. But the result at the end of the day, increased cost of fire and rescue services to deal with the call-outs and potential. And if they get it wrong, if their call challenging, fails in one day, and they decide not to turn out for something where they really should have, then clearly that could lead to a potential loss of reputation and some very big questions being asked. We know that with there being so many different fire and rescue service call-out policies, it is confusing for those who need to know, particularly with businesses. And it could be you could find a situation where people are actually, standing outside their building with a fire inside, expecting a fire and engine to turn up, not realizing that they need to take further action and make that 999 call to ensure that they turn up. And obviously there's a cost to business with little benefit, increased property loss by merit of delay, increased potential for lost life. I don't think anyone can argue with that. And if they're not doing any good, then potentially increased premiums. The only people who seem to benefit in all of this coping, amongst all the coping strategies, are really those maintaining the systems. And really we have an immense amount of maintenance and testing of these systems going on weekly, and really still not developing the rewards that we're looking for. So really the questions that we think need answering is really, how would the world change if a simple change to building regulations meant automatically generated alarms were 80% believable rather than 90% likely of being false or unwanted? And when you pose that question to those who it can impact, it's immense. It is such an enormous problem across the whole of the UK. We also need to ask whether the capability is already here. Do we have the equipment available to achieve this? What the barriers against adoption are? And if we do go down this route and we can find a solution, can this sort of high integrity alarm system, called the elusive common policy from fire and rescue services, really we need to be putting in place measures that support their decision making better, so they have a better chance of being effective where they really are needed. I have to have some sympathy for what they're having to cope with at the moment. And then if we do find a solution, how far should the initiative be taken? Are we talking to new and old commercial properties, residential? I think that's something to consider through building regulations. One of the biggest questions we have are standards and certification bodies ready? And we'll talk more about that at the end. And also all these things, when it comes to detection, which is a primary form of life safety protection really in the country, we need to think about this in the context of the other challenges that we're trying to address. Fire engineering, value engineering, heavily dependent on detection, budget constraints, we've seen how it can impact on that. We have no provisions in any of our regulation for property protection anymore, and possibly if we can get in some higher performing detection, then maybe we start to bring back some benefit to property and business protection there. And also, the economy plays a large role in how things go, and I think we know that we have a fairly underprotected estate in comparison to other countries, certainly around Europe and the world. So all these things I think could be influenced if we can improve things. So really the starting point is to accept that the heart of the problem is the smoke detector. It sounds like a simple thing to say, but the bottom line is they do trigger on many other influences than fire, and all initiatives to improve performance, the management, maintenance, use of heat detectors, placement, and all the guidings have really failed, and I think it's time we left those at the door. But there is a new breed of sensor, really often known as a sort of triple species or multi-species sensor, principally looking at smoke, heat, carbon monoxide, infrared, combinations of these. And the best guesstimate at the moment is that they have the potential to change this 95% plus disbelief into 80% belief. But it doesn't just stop there. They can be more resilient to abuse, potentially require reduced maintenance and testing, have reduced through-life costs. And actually, when we've looked into these systems, retrofit often only requires a head change and a reprogramming of the panel. But they are also more intelligent. They are more like sort of laboratory type sensors, and they can supply an awful lot more informative data, which could, if you're looking further afield, could be provided to the fire and rescue service pre-briefing en route through some of the onboard systems that they now have on fire engines. Now, looking at the smoke detectors, we know they're actually really just particle detectors, and particles can be generated from many sources: shower steam, fire associated but not fire challenges such as toasters and cigarettes, and dust from buildings works. Fire fingerprints, smoke, heat, combustion gases, visible light emissions, non-visible light emissions such as UV and IR, and motion flicker. And the idea of these sensors is as soon as you start to look for more than one fingerprint on fire, your ability to really start to determine as to whether it is a fire and help is needed becomes better very quickly indeed. So these combined heat, smoke, carbon monoxide detectors, they have an algorithm which can maintain detection time and increase reliability. As we said, suitability for head exchange only and panel reprogramming. And the thing that people are often stunned by now is the cost differential, which is always often cited as being the defining thing here. Actually, it's a lot less than people think. Possibly about £2 per detector is the best figure we have to date. So the other thing that can be done with these sensors is that another criticism that's leveled at them is they can reduce detection time. But we need to be clear on what we're looking for here. They can all operate as individual sensors: carbon monoxide, smoke, heat. You can always set a pre-alarm, a local alarm, to trigger on any one of those passing a threshold just to notify the local occupant. But in combination, you can then use an algorithm to determine whether you need a fire engine, whether that's developing into a fire. So there should be no deterioration in the system's ability to save local lives as a result of a change to this type of detector. But where it really improves is it can get around all of the call challenging necessary, because it can make a robust decision at the time when it's required of whether the situation is developing into a fire or not. Now, we had a play with many of these to many false and unwanted challenges in the Siemens test enclosure here, which is a nice environment to play and develop detectors in. It's a box which has basically controllable ventilation, scope to accept the full range of detectors. We can provide remote activation of fire scenarios, some of which I'll show you in these slides, and we can record what's going on and record the atmospheric conditions in there. This is what it looks like inside. Smoke extraction, you'll see smoke detectors mounted on the ceiling and a ring at the top. Wall-mounted beam-type detectors across, and that's really just to provide a comparator of the smoke density loading for the room itself. And one of the most commonly used triple IR flame detectors also. And then there's a frame on which fires can be mounted or challenges can be mounted, and a welding platform over, because that is a nice one of the nice challenges to present to any detection system, to see if you can differentiate between a genuine fire and something it needs to be more immune to. Now, in this particular study, we looked at 4 detectors, 2 conventional type smoke detectors, one ionizing and one optical. We looked at an intelligent version of a single sensor optical fire detector, and I think that detector has both forward and back scattering. And then the one I'm really interested in is the one at the bottom there, an intelligent multisensor. Now, this isn't a strict multisensor in that it's got 3 different ones, but we are doing some work with those now. So this one just has 2 forms of optical and heat. We are doing some further work on carbon monoxide, heat, and smoke. But even with this, if you like, it's a triple sensor in that has 2 smoke detectors plus heat. Its performance turns out to be impressively different to the others that are mentioned there. Now, when you're dealing with detection, you can set them to register in different thresholds, and in this case we used levels 1, 2, and 3. Danger level 1 is something which is under a pre-alarm event, so the detector knows that something's happening, but it's really not looking very dangerous. Danger level 2 is what we would normally associate with being a pre-alarm. We think it's going to get bad, and then danger level 3 is when it goes to a full fire alarm event. And this is what it sort of looks like on the test screen as more smoke is introduced into the enclosure. We can see the smoke graph, excuse me, top right. And on the bottom graph there, we can see when the different detectors actually go into these different modes of 1, 2, and 3. This is the sort of staple that we used. But there's another configuration that can be done in that these sensors can be also set to be appropriate for different environments, and they have configurations of clear, moderate, and harsh. Clear is something, a very clean room like offices and sleeping accommodation. Moderate is a setting used for most normal environments, and harsh is really for harsh environments like workshops and for where you need a high level of confidence that there is a fire before you trigger something like a suppression system. So now this does have an impact clearly on the detection times. So we're moving really from a hair trigger to something with a higher level of confidence. Now in simple detectors, this might just be a raised threshold of smoke concentration or a higher temperature value. But what it means with more intelligent detectors is the algorithm of the sum of the components that it's measuring may be treated differently. Now, we looked at a number of fire scenarios. Now, I should add that these fire scenarios were just done in the laboratory in the enclosure that I've shown. You'll see later in the video how we recreated these in environments such as laboratories and hotel rooms and workplaces. So this is really the sort of precursor to us getting to understand the detectors working. So really the fire and pre-fire scenarios, we looked at smouldering combustible materials, ignition of flammable liquid, and welding activity then leading on to the ignition of a flammable material, a not unlikely scenario. And for the false alarm section, or false or unwanted alarm, we looked at normal welding activity, generation of steam, and basically use of a toaster. So this is all very easy to understand. So in that enclosure, setting off some pieces of wood smouldering away to generate smoke, and we can see then the reaction of the different detectors as they go into the 3 categories of alarming that we have for them. So on the left-hand side of the screen there, we can see the smoke and heat being produced. In this particular situation, very little change of temperature, obviously, associated with smouldering of very small items, and we see an increase in smoke. And on the right-hand side, we have the performance of the different detectors with time. Now, there are two graphs here. So the top one is for moderate setting, and the bottom one is for clean and harsh settings. And in this particular case, we can see how the detector, the setting for whether you are looking at clean, moderate or harsh settings changes the response time of the detector itself. Now, smoldering fires are very difficult to deal with because you don't know how they're going to manifest with time. If we were using in this situation a detector that would actually monitor carbon monoxide also, then maybe the response might be different, because clearly none of these at this present moment in time are fires, but there's certainly a situation that might manifest in fire. So you can use your judgment as to whether it's appropriate to alarm for this type of fire under these circumstances. But if we look at a situation which is probably more obvious as to when you want an alarm to sound or not, then welding activity is a good one. So the jig on the left-hand side, what this basically does is has a welding arm and a spinning table, so it can have a welding activity going on continuously on that rotating table. And here we see on the graphs on the left-hand side, we see there's generation of smoke, very little heat associated with it again, but we can see a very different response from the settings for the more intelligent detectors here. And in this actual case, with a moderate setting on the right-hand side, at the top, you see that it's labeled as the FD00T241. Sorry, I should have changed these to more better titles. But you can see uniquely that detector, whilst it goes into the first state, it never goes into a pre-alarm state because it is not convinced enough that that is a fire scenario, which is exactly the sort of response we're looking for. We can see that if we then, with the other settings of clean and harsh, at harsh it doesn't even go into that possible event detected state, but on clean it does momentarily flick over. Now, I would argue again that if we were using a device which was a true triple sensor looking for carbon monoxide also, then that device would be entirely immune to this situation. KeppelSteam, another common one, which can set off fire detectors. There's our setup. Now again, here we can see a little bit more of an increase of heat, and we see the obscuration measurements on the left-hand side. And you can see that in moderate mode on the top right-hand graph, there is absolutely no response from the intelligent detector at all. That's not the case, though, when we see it set to clean for the intelligent detector on the graph on the bottom, whilst in harsh mode it remains undetected on the clean, when on the most sensitive setting it does show. So again, I would argue here, sorry, I think the title of that is incorrect. It should say KeppelSteam at the top of this slide. But again, it's a situation where obviously it's an environment where no carbon monoxide will be produced. And so again, I would say, and certainly it's what we're finding in the laboratory with the testing with the true triple detectors, that it wouldn't actually trigger at all under any circumstance. Now, when we actually summarize the data that we've seen, we can see that the optical detectors, the single-point optical detectors, whilst the have a level of performance, but are fooled on many occasions throughout, for even some of the challenges that we are seeking immunity to. And you can see as we go to use the intelligent detectors, we can see there's a lot more green on the page. It is very dependent on which setting is used, as you can see. But even with the medium setting, which would be normal, we can see that for all but toasting bread, we have a clean suite of detections where for periods when we wanted to detect, and we have no alarm or pre-alarm for where we don't want to detect. So even using this slightly limited device, in that really it's a 2-species device rather than a 3-species device, we can see the benefits of these going forward. So I think we can conclude here that better performance can be expected with devices incorporating carbon monoxide monitoring for smoke and heat. We've established the cost differentials are no longer a matter for consideration. But one of the biggest remaining hurdles that we have, aside from selling the concept to people, is that the standards for detector testing contain no requirements for immunity testing. And so long as that's the case, I don't think we're going to be making too much progress with this unless we can get people making improved design choices from the word go in the name of protecting their business and the peoples within. Really, the situation that we find ourselves in, I believe, is unforgivable in the context of the quality of the equipment that we now have access to. So really, it's all about convincing people. So I'd just like to hand over now to a video, it's about 12 minutes long, and we'll return just after. But this has been produced to assist with the selling of the concept, and we are very grateful to the support provided by the Fire and Rescue Services and the Alarm Receiving Centres for their participation in making this. But I think, I hope it'll be of interest to you.
The recent tragedy at Grenfell Tower has once again focused Britain's attention on fire. In fact, there are so many false signals that monitoring centre operators routinely call the source of any alarm to check whether there is a fire in progress.
Mr. Johnson, it's the Siemens Centre. We received a fire alarm from you. Is everything okay?
Residential's worked really well. We get about 96% success rate with that. The commercial, it's a bit more difficult because people who answer the phone don't always know what's happening.
The problem lies with the technology in traditional automatic fire detectors.
The sensors that are fitted to installations are not capable of discerning between different types of fires, and they can be operated by cooking, by steam, by smoking, by all sorts of things. And what we'd like to see is a far more intelligent system, a far more intelligent sensor that will be able to tell us what we're being confronted with at the scene and make a much more realistic decision about how we should respond.
One solution is a new style of multi-sensor fire detector. These respond to several different stimuli simultaneously, such as significant rises in temperature and the level of carbon monoxide, as well as the presence of smoke, to determine whether a fire has really started. This use of more than one indicator significantly increases the accuracy of the system's reporting and the level of confidence in the signals it transmits. This improvement does not compromise on safety. Occupants can still be alerted to a potential fire by an alarm tone generated from any of the individual sensors. If a multi-sensor detector is connected to a dedicated telephone line, the fire and rescue services can respond quickly and efficiently to automated signals, knowing the likelihood of this being a real fire is high.
Okay, if you just bear with me, I'll get someone on the way to us now.
False alarms are also significantly reduced, allowing the FRS to concentrate their resources on dealing with serious incidents.
AFA motorway services.
As the following examples show, multi-sensor alarms are much more reliable than traditional single-sensor alarms, and therefore more valuable to individuals, their insurance companies, and the fire and rescue services. Imagine a hotel. A tired guest is in the bathroom having a shower. They leave the door open, and within a few minutes, steam drifts into the bedroom and comes into contact with a single-sensor fire detector on the ceiling. On this trace of the detector's output, the red line maps the amount of smoke detected, whilst the white line shows the danger level, which will trigger the alarm on reaching 3. The steam hitting the sensor gives a high smoke reading, and it doesn't take long for the danger level to reach 3 and the signal to go to the monitoring center. Even though it's merely a steamy hotel room and not a potentially dangerous fire. Now imagine that this room had been fitted with a multi-sensor detector. Again, the red trace maps the smoke detected, and the white trace indicates the danger level. This time, though, there's also a green trace which maps the temperature. It's the combination of these readings that determines whether an alarm signal is sent, rather than triggering solely from the smoke reading. The sensor detects smoke when the bathroom door is opened and sees the initial rise in temperature. But as the temperature then starts to fall, it realizes this isn't a fire and the danger level remains at 1, preventing a false signal from being transmitted. Similar unwanted alarms can be generated by cigarette smoke. When cigarette smoke reaches a single sensor detector, it immediately prompts an alarm signal to be sent to the monitoring center, as if the room were on fire.
Hello, Mr. Fisher, still on the Siemens Centre. We've received a fire alarm from you. Is everything okay?
The operator challenges the alarm signal and eventually discovers that this is a false alarm.
Thank you. Thank you. Bye-bye.
Even if the fire and rescue services have not been called out, time and money have been wasted. If instead a multi-sensor detector had been installed, it too would have reacted to the cigarette smoke and set off a local audible alarm, but its carbon monoxide and temperature sensors would not have been activated, so there would have been no alarm signal sent to the monitoring center. However, if the cigarette had dropped into a bin and set some paper alight, the multi-sensor detector would have seen a rise in temperature and the carbon monoxide generated by the fire, as well as the smoke. It would have both set off a local alarm and sent a response to the monitoring center, prompting an immediate call-out by the fire services. A single sensor detector would have also sent a signal to the monitoring center, But due to the high incidence of false alarms, it would have automatically been challenged, wasting valuable time and potentially allowing the fire to escalate. Industrial processes are also responsible for generating a large number of unwanted alarm calls. Welding, for example, generates smoke and dust, both of which are liable to trigger a response in the single sensor device, which thinks that a fire has started and sends a false fire signal to the monitoring center. Contrast this with the response of a multi-sensor device. It too will respond to the smoke, but because the carbon monoxide and temperature sensors are not affected, it will not send an automatic signal to the monitoring center. However, if a spark from the welder ignites something else in the workshop, then the rise in temperature and carbon monoxide would be detected, prompting an automatic response which should lead to an immediate call-out by the fire and rescue services. These scenarios all illustrate the same problem. Traditional single-sensor fire detectors often can't distinguish between genuine fires and false stimuli. This results in thousands of false alarms every year and the significant waste of the fire and rescue services' time and resources. They can also lead to unnecessary delays when dispatching appliances to real fires, while the alarm signal's integrity is checked.
Right, okay, so you're not able to confirm for me if there's any signs of fire? Do you know if the sprinklers have activated?
Multi-sensor detectors are far more accurate at identifying genuine fires, so reducing false and unwanted alarms and allowing the fire and rescue services to concentrate their resources on genuine emergencies. They cost little more than traditional single-sensor models and can be retrofitted onto existing systems and wiring, requiring little more than reprogramming of the alarm panel. Importantly, they can also be individually tailored to their environment. So a sensor fitted in a hotel kitchen can be set to react differently to one in a hotel bedroom.
That would mean that the activations that come through, we could deal with them. They're probably going to be the genuine ones, which we can get out to fire and rescue services.
That will enable us to direct our resources much more effectively to where they should be. It will reduce cost, and it will make our public and our firefighters safer.
Grenfell Tower showed all too clearly the devastating consequences of a major fire. The overhaul and modernization of these critical, life-saving fire detection systems is long overdue. Multi-sensor detectors save time, save money, and will ultimately save lives. The recent tragedy at Grenfell.
Right, well, thank you very much for staying with us during that. I do apologise for the loss of sound initially. I think the system doesn't quite work the way we thought. But the purpose of making that video, I hope you understand, is really to start to get the conversations going about whether detection can be put in a much more effective fashion to achieve a higher set of goals than we are currently managing. Now, for many of you listening, that might have sounded a little bit ladybird bookish, but you must remember it is for an audience of your customers who this isn't their day job and they don't understand the situations and the challenges, or that there are offerings over and above possibly the bare minimum that they might be offered if you ask for nothing else. And I think so much with what we're trying to do at the moment is getting people to know that there are choices to be made, and that really if you don't engage, then what might be delivered to you is really adhering to a rather low and grey bar of building regulations requirements. And really there's so much they could be investing in to protect themselves and their businesses and their properties. So hopefully the video, there's a link on the final slide as to where that can be found. Certainly value your feedback. I think certainly it may be worth making in a slightly shorter form than it currently is. But hopefully you'll appreciate or value your feedback. But I think it is doing a job that needs to be doing, particularly at this time. So I think I'll probably end with on that as a subject matter. Value any comments you've had. just while that film was playing, we had nearly 300 people listening in, which is very good, and I hope it's been a worthwhile hour spent with us. But just to close, I'd just like to draw your attention to the Manchester seminar, which is coming up very shortly. We have a very good list of speakers, as usual, trying to remain topical and bring up some new and exciting areas for you, and I do hope you'll be able to join us. It will be repeated in London, and I think that is on the 1st of November. But it will be very good if you can come and join us then. So I'd like to thank you all for listening in. That is the link. The slides will be made available online as usual. And what we will do is we shall also post up the video separately for download. But if you have any comments, we'd certainly like to hear back from you. So I don't think we've had too many comments. I'd just like to close by saying thank you for the sponsors of work, ABI. And there will be a